In this lesson, we are going to discuss equivalent fractions. And we have only two objectives here. First, write a fraction in one of its equivalent forms, and also to represent simplified fractions with a picture. Now, a couple things that you need to be able to do. You have to be able to multiply and divide, and you need to be able to count as well. For instance, what fraction is this? All we have to do is wind up counting. We can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can see that 6 of them are shaded out of the 10 possible chunks. That's our fraction, 6 out of 10. Equivalent fractions exist because you can actually write the same number using different ratios. In particular, we had this fraction written out 6 over 10, but we could have grouped these blocks a little bit differently. And if we group them in chunks of 2, that's 1, 2, 3, 4, and 5. If we looked at them this way, we've got 1, 2, 3, 4, 5. This is 3 shaded out of the 5, and yet it was the exact same picture. This is an example of equivalent fractions. It's the same thing written with two different sets of numbers. 6 out of 10 and 3 out of 5 are an example of a ratio. Ratios are nothing more than a comparison of two numbers, and we usually write them in a fractional form. So, we're curious then about here. Within this block, we're missing a number, and we want to figure out, like here, what the 4 numbers are. Well, in order to get that, we can do and simply say, how would you turn a 2 into a 4? You'd have to multiply by 2. Well, we need to do the same thing to the top. If we take that and multiply by 2 on the top as well, 1 times 2 gives us our answer of 2. We're done. Now, I do want to emphasize, you do not have to write down this times 2 stuff. Those are things that you would look at and you would think in your head. But that's all that you would need to have written down. For instance here. And I'll write it down again so that you can see what I'm thinking. When I look at this problem, I'm thinking, how do I turn a 2 into a 6? I have to multiply by 3. Well, doing that same multiply by 3 in our numerator, I can figure out what my answer is. And so, there I'm done. These pieces, again, don't need to be written down. Those are just your thoughts. What about here? How would you turn 4 into 20? Multiply by 5, so 3 times 5, 15, and we're done. How would you turn 4 into 80? And you'll notice we're doing the same thing, and it doesn't matter where the missing chunk is. To turn 4 into 80, we have to multiply by 20. So 5 times 20 gives us 100. And we have our equivalent fractions. What about here? We're going to shade them. We're going to note this particular one is the fraction 2 out of 5. And when we count down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What would the top number be? Taking times 2, it has to be 4. So what we need to do is shade in 4 of them. take 1, 2, 3, 4. You'll note I'm not spending a whole lot of time trying to make sure it's absolutely, totally, and completely perfect. It's not important. It's important to demonstrate that you understand. Of course, we can apply these concepts to word problems as well. You eat 2/3 of a pizza. Well, we could write that pizza fraction as 2/3. That pizza has 12 pieces in it. Well, 12 pieces would be the whole thing. And so, since that's the whole thing, that's the total that goes down onto the bottom. And so just writing and reading it out, we can identify we're setting up this piece, and our question then asks, how many slices of pizza did you eat? That's nothing more than finding the missing chunk in our equivalent fraction. So, what is that missing chunk? Mentally, we can look at it and see that to turn 3 into 12, we'll have to multiply by 4. So 2 times 4, that gives us 8. And we have our answer then. You ate 8 pieces, or 8 slices of pizza. And that's all that we needed. We were able to accomplish all of our objectives. In looking at these, we know that we can write fractions in their equivalent form. It's just based on multiplication. And we also saw how we could write out fractions using a visual model.